Hello, everyone. I'm meteorologist Sean Sublett, and welcome to Across the Sky, our national Lee Enterprises weather podcast. Lee Enterprises has print and digital operations in 77 locations across the country, including in my home base in Richmond, Virginia. And I'm here with my meteorology co-hosts from across our network, Kirsten Lang in Tulsa, Joe Martucci in Atlantic City, and Matt Holliner in Chicago. So just to be clear, we are recording this a few days before Fiona makes landfall in Atlantic Canada. And there's already a lot of buzz about a new storm about to take shape in the Caribbean. So we'll get to all that in just a minute. But first off, I want to go to Kirsten. When there's this much buzz about something developing in the Caribbean and maybe affecting the East Coast, how do people in Oklahoma kind of take this?
I think they like to be in the know, but this is something I was actually going to talk with her about, is that it's or our guest about, I should say. We haven't introduced her yet, but our guest is, why would it be so important for Tulsans to care about this? I think they like to be in the know, but it doesn't always impact us, of course, as much as it would you, Sean, or Joe, being along the coastline. So, whenever I do forecasts, I like to update my viewers on what's going on, but we don't dive into it maybe with as much time and detail as those living on the coast would.
Matt, what about you? I mean, you're even farther north away from the coastline in the upper Midwest, Chicago, Minnesota, down in Nebraska. What did the people there think when they hear all this buzz about something in the tropics?
Oh yeah, it's definitely different when you're on the coast versus not on the coast. When you're on the coast, anytime there's the potential for something, people want to know, like, well, what are the models saying even before it develops? That's what we're dealing with this one system right now. But for folks in the Midwest, it really is only after the system has formed, and also only if there's going to be impacts in the U.S. Like, there was some interest and buzz around Fiona when it was impacting Puerto Rico, but now that it's just out in the Atlantic again, like, nobody really cares. There's no point even wasting time talking about it because it's not a threat to the U.S. So folks in the Midwest, I mean, of course, sometimes they do work over the Midwest. That's what people think. Maybe the Midwest is it is not free from the impacts of these systems. It's just a lot less common. And so in general, people have an interest, but only when there's a threat to the U.S. and the actual system has formed, not when there's the potential. But boy, it's a different story. When I was in the Rio Grande Valley in South Texas, people want to know anytime there's the potential for something to form, particularly if there's a chance it could go on the Gulf. They want to be informed as early as possible, and they want a tropical update in every forecast, but not needed in the Midwest.
Joe, how was everybody on the Jersey Shore handling it so far?
Really our biggest impact is the deadly rip currents and the surf that's going to develop this weekend. Unfortunately, we've had a couple of people die in the Jersey Shore due to rip currents. So that's really the main point I've been hammering over and over again. There is this conundrum that I feel like isn't spoken about, but I'll just say it here while we're on the pod. Surfers love this, but you can't say, hey, surfers, go out and enjoy this, because it's irresponsible as a meteorologist, because you don't want to give the impression that the waters are safe. The waters are not safe. Only if you're very experienced is it something that you maybe would consider. But the impacts of this high surf and the rip currents is something that we're focusing on. And, again, I get it's good for the surfers, but majority of people out there are not surfers and are not experienced swimmers. I mean, I'd like to think that I'm a good swimmer, but I'm not compared to some of these surfers out there. So it's definitely a conundrum for me, but also, let's just say what it is. It is deadly surf and rip currents as we go into this weekend.
Yes, rip currents.
Which is going to be last weekend by the time people are listening.
Yes, but we still have a lot of tropical season ahead of us for sure. With that, I want to bring in our guest, Jhordanne Jones. I love the fact, Jhordanne, that you are a native of the Caribbean. I think that speaks volumes to the importance of the perspective that you bring. Jhordanne's a postdoc continuing to study hurricanes and other tropical cyclones at Purdue University in Indiana. She kind of came through the Colorado state system for a while, getting her PhD there. And those in the know, some of the more foundational work in seasonal forecasting of tropical cyclones was done there at Colorado State. Bill Gray, Phil Klotzbach, and the group there. So, Jhordanne, thank you very much for joining us today.
Yeah, it's great to be a part of the podcast again. Right, Joe?
Yeah. We go way back. We were trying to say, was it a year ago or 2 years ago on our local podcast? Shout out Something in the Air podcast, pressofac.com. We were talking about hurricane season back when we were at Colorado State. So it's good to see you and hear from you. And I think Kirsten, Matt, and Sean are all really gonna enjoy this. I hope everybody listening enjoys from Jhordanne, because she's really a wealth of information, and given where she's from, tremendous experience as well.
Absolutely. So the first thing I want to kind of attack, Jhordanne, is I think as meteorologists, I don't think any of us are shocked that the season kind of got off to a quasi late start, but compared to the last two seasons, the first half of the season was not nearly as active. And I do think that even surprised some of us in the hardcore weather community, as the seasonal forecasts, not as intense as 2021, but was still expected to be quite active. Obviously, it's very active now that we're into the latter half of September. Did you see anything, or has the community who does seasonal forecasting have any kind of first ideas to why it might have started a little more slowly?
Yeah, so there's a phenomenon called Rossby wave breaking, which is essentially when you have a lot of dry air intrusions from the mid latitudes or the higher latitudes into the more moister tropical regions. And when that happens, when you have a constant mixing of that variety, then you tend to have two things happen. One, there's an increase in vertical wind shear because there is air making its way south, right? And it means that there are essentially two, how would I put it, two bodies of air crossing each other at different directions, different speeds. So naturally, there's a change in vertical wind shear, which is detrimental to hurricane activity and hurricane development. And the second thing that happens is that you have more dry air that's mixed into the tropical region. And that just essentially dries out the mid levels. It means that there's a suppression of moisture that would feed hurricanes in the first place. So Rossby wave breaking actually happened. It was also a really effective way to suppress hurricane activity in 2013, probably more effective than it has done for 2022. So my answer would be Rossby wave breaking. It's not one of those phenomenon that we tend to pay a lot of attention to, especially when ENSO or El Nino Southern Oscillation, when you have cold anomalies in the Eastern Pacific, tends to be favorable for hurricane activity.
All right. So for those who aren't familiar with Rossby waves, which, as I know, probably a lot of folks listening, these are these big jet stream waves that we talk a lot about. So are you saying when I'm trying to visualize a Rossby wave kind of breaking, is this kind of to suggest that there's more kind of dry air intrusion into the tropics than from the middle and northern latitudes? Is that another way to think about it? Just like the general flow is just kind of inserting more dry air farther southward or equatorward than we normally see. Is that fair to say?
Yep. So if you think about there being an imaginary line between the tropical region, let's use Florida as a point of reference. So anything above Florida, think of this invisible line that just cuts across Florida. And then think of that line becoming curved because of some wave, right? It goes up and down, and then at some point, it just decides to keep going around and around, right? You can also think of an ocean shore and watching waves break onto that shore. And it's the same thing, right? Where you have this boundary that just breaks and continues to mix, Another way to put it is that the dry air intrusions, they have crossed this boundary and there's no reversing that boundary. So there's no distinguishable feature between the mid-latitude environment and the tropical environment, So that's essentially what Rossby wave breaking is. It's just these waves that break, and they can't be reversed. So it means that the tropics loses that moist air and gains a lot of dry air. And that is essentially, just making the tropical environment more unfavorable for hurricane activity.
We also have seen these last several weeks that the northern Atlantic has been much, much warmer than normal. The sea surface temperatures have been a lot higher than normal. And I think some places, I'll say 4 to 5 C, meaning, almost 7 or 9 degrees Fahrenheit. Is that what I'm remembering correctly, Jhordanne, or is my mind a little off?
For this time of year, it's probably
the anomalies.
Probably around, the anomalies themselves. It is warmer.
Yeah. Okay.
It is definitely warmer. Probably not by a lot, but just enough that you'll have this outbreak of hurricane activity in the late hurricane season.
But you don't think that the anomalies in the farther North Atlantic, let's say north of 40 or 45 degrees north, have played much of a role, or is that just kind of like, well, they're going to be stronger longer and farther north because it's warmer?
Oh, that is much harder to explain.
I'm sorry.
No, it's fine. So there are a lot of phenomena that feed back onto sea surface temperatures. I've already mentioned El Nino Southern Oscillation. That's definitely one. Rossby wave breaking also has its feedback on sea surface temperatures. Really warm SSTs further north, above 45 degrees north, is also an indication of Rossby wave breaking. So it can mean that you have more hurricane activity, assuming the shear is, not a factor. More hurricane activity further north in the subtropics rather than the tropical region. If there's warmer tropical Atlantic SSTs, then you may have hurricane activity forming further down in the tropics rather than the subtropics. So SST patterns are, very essential when it comes to seasonal forecasting.
I'll hop in here, and just for, to get everybody on the same level here, could you explain, as we go from May into June and July, so on and so forth, where those tropical development regions are, and then how they expand and contract throughout the course of the season, and how that relates to what we're seeing right now, given that it is September?
Yeah, SST patterns are just so much fun. So earlier on in the season, when we're talking about May to June, sea surface temperatures get really warm near the Gulf of Mexico, in the Western Atlantic. And then as it starts to warm, let me backtrack there. So presumably it gets warmer first in the Gulf of Mexico because the topography, the ocean is just a little bit shallower there. And then as the entire basin starts to warm up, those SSTs sort of migrate to the central Atlantic. And then later on in the season, peak season, it's everywhere is just warm. And then late season, the September to October, November, it migrates back to the Gulf of Mexico. So naturally, tropical cyclone Genesis, where storms tend to form, that also follows the SST migration along the seasonal evolution of SSTs. So Gulf of Mexico is definitely where it would start. So A, B's, C's, named tropical storms tend to be in the Gulf of Mexico, and then everything else goes to the central Atlantic and then makes its way back, central Atlantic, subtropics, and then makes its way back in the late season towards the Western Atlantic.
I'm going to jump in real fast too. So things have been suppressed by these Rossby waves, but they're still it's still being called for to see an above average season. Can you explain why that would happen, even though this has been such a late start?
That is a great question with no easy answer. This is the part of tropical cyclone activity that gets scientists so excited, I think. Tropical cyclones have their own kind of structure. You know, every one of them is unique, and at every point in time, or maybe one point in time, there's always a storm that just exceeds everyone's expectations. Like it is well insulated from the effects of the ambient environment. Therefore, the vertical wind shear. Fiona is a great example of that, right? So there's a lot of shear around it, but its bands, its rain bands are incredibly wide, and it's pretty much insulating that core convection and that core region, the eye of the storm. So it is, in fact, I think, very probable that it will survive the harsh environments of the subtropics and the mid-latitudes. We saw that also with Dorian in 2019, where there was a lot of, mid-level dry air, right? A lot of dry air around it, insulated itself. I don't know, it was just particularly resilient. And it made its way out of that shear. And once it got a patch of really warm, really moist air, it spun up and went on to impact Bahamas. So I'm not quite sure how that happens, because it tends to be very unique with each storm. But when a storm is resilient to the environment it's in, it becomes the most powerful, right? And it goes on to cause the most damage. So, I don't know. It's fascinating to watch it.
And I want to jump in with some context. We're talking about an above normal season and a normal season. So what is a normal season? And we've got the numbers from NOAA. Looking at 1991 to 2020, a typical Atlantic hurricane season has 14 named storms, 7 hurricanes, and 3 major hurricanes. And so where we stand right now is that we've had 7 named storms. So we're right in the middle. An average season has 14 named storms. And then also, to put it in a little bit of context, you can look at the date when we should see that 7th storm form. And on average, the 7th named storm usually forms by September 3rd. So right now we're trending a little bit below normal. It's now September 22nd. We're just on storm number 7. Usually by September 22nd, we should be on storm 10, and we're still just on storm 7. Now, there are several other areas to watch. So that number is, I think, going to rapidly, at least it's looking that way right now, will be increasing. But just to put it in context, like right now, because of that late start, we are a little bit below normal. But are there any signs? Because remember, hurricane season does go until November 30th. And I think people often forget that we have the whole month of November, because usually not a lot happens in November, but maybe this year is going to be the exception. Are there any signs to say that this increase in activity is going to slow down anytime soon? So maybe we're going to play catch up a little bit here at the end of September, October, and then possibly in November?
Yeah, that's a great question. So let me first start off by saying that there's a difference between the official season and the climatological hurricane season, right? The climatological hurricane season suggests that you can have storms as early as April and as late as December. Right. You can, if the environment persists well into December, you will most likely get a storm in December. And the official hurricane season is there to give structure, to make sure that people are aware and that they're paying attention when the peak of the hurricane season is upon us. Right. So in terms of this particular season, it is highly likely to actually persist well into the late season, the late part of the season, and that is probably because one, ENSO, the El Nino Southern Oscillation is currently in a La Nina state. It means that there are strong cold anomalies within the eastern equatorial Pacific. And just to give a brief definition of why ENSO is so important for us, it actually that phenomena controls a lot of the winds that occur along the tropical belt, especially for the Atlantic. And because we are so close to the Pacific, there is a stronger forcing of that ENSO state. So when we have a La Nina, we tend to have a lot more hurricane activity. If you can, it's kind of like La Nina sort of opened the floodgates. Essentially, it makes the Atlantic incredibly favorable for hurricane activity. If that state, or if that phenomena continues into November and December, which it is forecasted to, then you can definitely have the hurricane extending well into the late season. So there are definitely indications that that this hurricane season might do a 2020, 2021 kind of thing, where it just extends later down.
Oh man, yeah. So I'm with you entirely there, Jhordanne. I think this, last year it kind of shut off pretty quick, but I'm kind of with you here. I think this is it's going to go on for a while. We're going to take a little break here, and then we come back and want to talk a little bit more about these last couple of seasons and La Nina and where we think things might be going here in the coming few seasons. So all that when we come back with Jhordanne Jones on the Across the Sky podcast.
Make a difference. Relish a great work-life balance. Enjoy generous benefits and competitive pay. Go home each night feeling fulfilled by your work. Work for an employer of choice. Work for Blue Ridge Hospice. We're always looking to hire compassionate RNs, CNAs, or anyone interested in office or thrift shop work. We've been your not-for-profit community hospice since 1981. Visit our website for more information or to apply today at blueridgehospice.org. That's blueridgehospice.org. Blue Ridge Hospice is an equal opportunity employer.
And we're back on the Across the Sky podcast, talking about hurricane season and all things tropical meteorology with Jhordanne Jones from Purdue University, a postdoc who's doing research there in seasonal forecasting. And one of the things I wanted to check with you about, and we kind of kidded around about this during the break as a little informed speculation, is that, both 20 and 2021 were exceedingly almost off the charts busy. And I worry that those kinds of seasons back to back put this idea in people's heads that it's always going to be like that from now on. And that's really not the case. Compounding that issue, as we alluded to before the break, we're going to a third season now with the La Nina, which also corresponds to active hurricane seasons. So how do you think things play out in the coming 3, 4, 5 seasons? I mean, do you have anything that's out there that you could say, look, 2020, 2021, they were off the charts. Don't expect it to be like that. Having said that, things were probably going to be busier than they were, let's say, in the 1980s. I mean, what kind of messages do you, or ideas do you like to pass along to people after we've had these two just mammothly active seasons?
The first thing that I'll say is I'm going to sort of copy Phil Klotzbach and CSU's forecast here. And their main message that always comes out when they put out their seasonal outlooks is that you do not need an above normal tropical cyclone forecast or season for it to be active for you. If you get one storm and that storm hits you, that is certainly an active season for you. All right. So it takes only one storm, right? So in that sense, we should always be prepared for hurricane seasons. And 2022 is actually a great example of that because Fiona has been like the threat, right? Even though it was slow in the first half of this hurricane season, it's starting to pick up now. So with that, let me explain ENSO a little bit. So ENSO is this interesting phenomena. It has oscillations, meaning it goes up and it goes down, and it can go up and down for years, and it can change even less than that, right? So it can change from month to month, and it can also change from year to year, and then 3 years or 7 years even. The idea that I want to say here is that ENSO is in fact very variable, and it makes hurricane season very variable as well. And it's hard to say that just because these 3 seasons have been particularly above normal, that the next 3 seasons will also be that. What else do I want to say? Even when you look at 1991 to 2020, which is our new normal, which is also above normal in and of itself, there is a lot of variation that has happened. 2013 was one of the lowest in ACE that we ever had. That did not happen anywhere else. I think the other ones were like 2002 and 1994 even. But that is really just to say that we have had literally the most active and the least active years in what we call the era of above normal activity, right? So to say that we had like this triple dip La Nina pattern for the past, 3 or 2 years does not say or does not give the whole picture for hurricane activity. So please do not, count on there being an El Nino or there being a La Nina to prepare for hurricane season. Stay prepared. That's my message.
Yeah, and one of those seasons was I think we just said it, Andrew, 91. Which shaped South Florida, still does to this day with its building codes here. And I'm just trying to think from a messaging perspective, for places that are up north and thinking about like Nova Scotia, even here in New Jersey, places that don't regularly see hurricanes. In fact, in New Jersey, our last landfalling hurricane was in the 1900s, as in like 1903, 1900. But yeah. What's your messaging for places like those that, aren't seeing the direct impacts of a hurricane very often, but could see tropical storms or could even see remnant systems as well?
Joe, that's a great question, because you have picked on my bugbear.
I didn't mean to make it too difficult.
No, it is not difficult, because I have thought about it for so long, and every hurricane season I have to contemplate it. So here's the thing. Hurricanes do not have to make landfall directly to have indirect dangerous impacts, right? You mentioned remnants, which essentially means that the remaining convection from storms essentially what we call reinvigorates or reintensifies to impact people at higher latitudes. Those have really strong impacts because they can still lead to flash floods and flooding, depending on how fast it moves and how fast it dissipates. So there are both direct and indirect impacts from storms. Two, that impacts are not strongly correlated with the intensity of that storm, right? So remnants can have dangerous impacts. Tropical storms can have dangerous impacts. Extratropical storms can have dangerous impacts. Sandy in 2012, even though it did become a particularly intense storm, had other things that, other events that caused it to be as impactful and as dangerous as it was. So, I know we like to talk about, we get really excited or panicky about category 5s. You probably should be panicky also with tropical storms and its remnants as well.
For us in New Jersey, we had the remnants of Ida come through the last day of August, and that was the second most deadliest storm in terms of a tropical system in New Jersey history behind Sandy. So at least in the modern era. So going right into your point there.
Right. Yeah. And I just want everyone, everyone at home to just get up and then just shout at your politicians that, tropical storms and remnants are a thing, and they can potentially be dangerous to your livelihoods and your lives as well. So, you need to bully your politicians as well.
And Jhordanne, what do you think are the next steps for improving the forecasting of hurricanes? Not only, forecasting the potential for them to form, so improving seasonal forecasts and improving the forecast for these hurricanes as they're ongoing. And I think one of the big things that stands out to me, we haven't had a great example of it yet this season, but in the last couple seasons, one of the things that's been so difficult to forecast, the track forecasts keep getting better and better, but the intensity forecast and really being able to nail down when a hurricane is going to go under that rapid intensification. Because that is key for, especially when these things get in the Gulf, when is that going to occur, and the eye wall replacement cycles? What can be done to improve the accuracy of those forecasts in the short term, but also the seasonal forecast? What do you think are the next steps, and what really needs to be worked on to improve forecast accuracy for hurricanes?
Let me tackle seasonal forecasting first. So there are a lot of things that impact tropical storms, tropical cyclones that are not yet accounted for in seasonal forecasts, right? Rossby wave breaking is one of them. CSU is one of the first, I think, to actually try and incorporate a statistical predictor that tries to, to account for that phenomena. With varying effects, but we still have no real sense of how we can predict the actual phenomena, right? And we've only just started to put them to test its predictability. So there's that, and it's probably not just Rossby wave breaking as well. There's the Saharan air layer events that are inconsistent predictors, right? Sometimes it works, sometimes it doesn't work. And other remote impacts, meaning phenomena outside of the basin that just isn't there or rather it's very difficult to incorporate into a seasonal forecast. To your point about intensity, you are very correct. Intensity is a very hard thing, in my opinion, to forecast for, especially when you have everywhere in the Atlantic being warm. It's hard to pinpoint where exactly rapid intensification might occur. And there's definitely been a lot of research on that, and I don't quite think that people have figured it out just yet. We haven't figured it out just yet. And I don't know, how do you, when we see the tracks, when they put out the tracks and the forecast tracks, just a reminder that the tracks are essentially positions of the storm stitched together in space and time, right? And there are times when the hurricane itself or the storm itself isn't really being monitored. Yeah, it needs to be at a resolution that is actually computationally expensive. So we have 6 hourly data, or maybe hourly even might not be enough to capture those changes necessary to actually predict intensity. So we're left with kind of using environmental predictors, using dynamical models to sort of extrapolate or interpolate whichever when intensity might occur. And unfortunately, the best we have now is still guidance, or what people like to call the subjective methods, just years of experience about when a storm might occur. The Dvorak technique, Vern Dvorak, I don't know if you heard, actually just passed. So yeah, we lost another one. But yeah, we still are very dependent on the Dvorak technique, satellite images, to really pinpoint when and in what phase a storm might be in.
Yeah, I did not know that about Dvorak. Yeah, that's a real shame, because that is something that, I mean, again, the people listening to this may not have heard of that, but that's something that's very familiar with meteorologists in the analysis of the satellite images to not only figure out how strong a storm is, but you're right about when it might be undergoing some intensification or weakening. That is a critical component. So that's just the thing, I think a lot of the public thinks, it's all about the computer models for meteorologists, and they absolutely are our biggest tool. And we would not be nearly as accurate without them. Thank goodness for them. But it is not, we are not just the computer models. That's why, we don't just hand the job over to the computers and say, you're the meteorologist, computers, go. There's still that human element, and there are other things that we analyze. And the satellite imagery is a huge part of that, especially when it comes to hurricanes. And then it's also identifying, looking at the models and figuring out where the models are doing good and where the models are going bad, and figuring out which model is the best. So the computers haven't replaced us yet. I think they're quite a ways off from doing that. And the Dvorak method is a great example of how, the computers aren't doing that just yet. So we're still important as meteorologists.
Joe, did you have some?
Oh, yeah. Sorry about that. I thought you were saying something, Sean. I saw you on the. I thought you were reaching over for the mute button on the Zoom here. When we think about the hurricane accuracy over the past, 20 or 30 years, could you explain to us how much more accurate we've gotten in both the intensity side as well as the track forecasting?
Unfortunately, I can't, because I don't think I know the specifics of how they do. But I know certainly that improvements in our remote sensing methods, in our data assimilation methods, in the overall improvements of these models have definitely improved over the last decade, rapidly improved, right? We have techniques, remote sensing techniques that allow us to really increase the resolution of not only our forecasts, but the observations that go into the forecasts. We also have a lot of people working on creating even more powerful models, and it's not just the numerical models. There's also global climate models that are starting to come to the fore, perhaps not for directly forecasting for hurricane activity, but certainly for forecasting the environment and the climate system, the Earth system as a whole. Reanalyses is getting longer and bigger data is coming to the fore, and there are tons of people that are coming in and analyzing all of that. So all of our reanalyses data sets, which is essentially just a combination of observations and model data, is getting longer. It's going back in time, extending further back in time with what we think is more reliable data. So there has certainly been a lot of improvement in our systems of observation, with our models, with our forecasts. And at the same time, there's also much farther to go.
Yeah, there's no question about that. And, and people do ask a lot about, climate change and hurricanes. And I think we all need to remind people that, a warmer environment means more evaporation and heavier precipitation. But there's nothing to suggest that suddenly we're going to have a whole lot more hurricanes, just that they will tend to get a little stronger, tend to go a little farther toward the north, in this case, the pole, and produce more rain. I mean, but back to environmental things. And before we wrap up, one more question before we cut you loose, Jhordanne. Thank you. I've heard a lot in the last year, maybe 18 months, about the Atlantic multidecadal oscillation. And that's something I think a lot of us kind of grew up on coming through academia, and how there are these periods that are more active than others. I mean, 20, 30, 40 year periods that are more active than others. But there's more of this kind of idea bubbling up. And I would like you to comment on it, that some of these less active periods in the mid to latter 20th century may have been more due to the fact there was more aerosols in the atmosphere from human pollution, fossil fuels, that kind of stuff, and that the actual ocean temperature multi-decadal oscillation may not have been as much of an impact. And now, since a lot of that particulate or aerosol matters is settling out, since we don't do as much, since we put scrubbers and the environment is not as classically polluted as it was, let's say, in the 50s and 60s, that may be more of a role in hurricane formation or inhibition than straight AMO. That's complex. I know that's a thing that's kind of bubbling. I don't know if you have a comment on that. You think it's bunk, or we just don't want to touch that yet. But I just want to get your thoughts on that before we close up, if you feel comfortable sharing them.
Yeah, I can. I always have opinions. So
Not always a bad thing.
Yeah. Okay. So you have put together, I think, two very complex phenomena. One, the AMO is essentially just oscillations in Atlantic sea surface temperatures and sea level pressure, if I remember correctly. And it happens on multi-decadal timescales. It still has its own impact on hurricane activity, partly through the decadal variability of hurricane activity. It has its own impact, and it probably has its own impact on larger timescales than, let's say, aerosols. I have seen research about several aerosols. One in particular is volcanic activity, and does volcanic ash actually do anything or modulate tropical cyclone activity, or even sea surface temperatures? And I guess the short answer is yes, but it depends. And it depends on the aerosol that you're looking at. Is it carbon dioxide? Is it volcanic ash? Is it, Saharan African dust? It'll change. The third concept that I want to mention, and I sure hope it doesn't confuse your audience, that you can have what we call feedbacks. So you can have one phenomena do one thing to hurricane activity and it be countered by another phenomena, countered or enhanced by phenomena. And it is, I think, uncertain to me how aerosols by itself could counter the impact of Atlantic multi-decadal oscillation. It's very, very complicated depending on the aerosol that you look at. But I would say that sea surface temperatures are very likely, the kind of reign supreme when we talk about hurricane season. Everyone will look to sea surface temperatures first. And I would say that the Atlantic multi-decadal oscillation is still a pretty strong predictor, even on decadal and multi-decadal timescales for hurricane activity. Not discounting aerosols in any way. They're in their own ballpark. But yeah, that's my answer.
Okay, that's fair, because again, this is one of these things that I've only seen bubbling up in the last 12 or 18 months. And the point is we're always learning, right? The community is always learning, right? We only have hurricane seasons, once a year. So it takes a while to learn these things.
It does, yes.
And that's why we continue to work to understand and better prepare. Jhordanne, we're going to cut you loose. So thank you so much for joining us today. I appreciate it.
Yeah, I appreciate it as well. I love the questions. They were really good questions. I'll have to keep them in mind for future interviews.
Wonderful. And it's always fun having you on. So again, Jhordanne Jones from Purdue University, West Lafayette, postdoc doing good hurricane research there on seasonal forecasts. We'll cut her loose. We're going to take a little break, and we'll be back to wrap up on our Across the Sky podcast.
Michael J. for Hope for the Warriors. Started back in '06 at Camp Lejeune. Military families witnessing the effects of war on their loved ones. Now, almost 20 years later, they've aided over 53,000 service members, veterans, and families with confidential, high-quality behavioral health care services at little or no cost to post 9/11 vets and their families. Over 91% of every dollar donated goes directly to the programs. If you're as concerned about our heroes as I am, go to hopeforthewarriors.org.
And we're back with our final segment of the Across the Sky podcast. I'm meteorologist Sean Sublett. Before we completely wrap up, let's take one more quick break and look a little farther up into the sky with our buddy Tony Rice from NASA.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook.
You might have noticed what looks like a bright star in the eastern evening sky. That's Jupiter, and it's at its brightest this week because it reached opposition or directly opposite the sun in our sky. Opposition in 2022 is even closer because it occurs close enough to perigee, or that point in Jupiter's not quite circular orbit where it is closest to the sun. Jupiter's actually closer than it's been in 59 years and won't be any closer for more than 4,300 years. And even then, it'll just be 437 miles closer. That's not a lot when you consider it's over 367 million miles away. Yes, I did all the math. That decreased distance does a lot for how bright something appears. The equation for apparent brightness takes the light energy being emitted by the star, or in this case, reflected by the planet, divides it by the square of the distance, so further away objects get really dim really fast. Think of this the next time you're looking at a bright star like Sirius in the constellation Canis Major or the Big Bear. It's more than 8 light years away, yet it shines as the brightest star in the night sky. That's a pretty bright star. Elsewhere in the sky is our own star, the Sun. It's spinning 12 hours above the horizon, or close to it. While last week was the equinox, this week is the equilux. If you're in Canada or the northern half of the United States, your equilux happened on Sunday. It's Monday for the middle states and Tuesday for more southern states. For more on why this happened several days after the equinox, check out last week's podcast. That's your Astronomy Outlook. Follow me at RTP Hokie for more spacey stuff like this.
And Tony is a great follow on Twitter. RTP Hokie is his handle there. All right, guys. So Jhordanne's always great to have, obviously. A wealth of information. She's very much in the thick of hurricane research. And I think some of the things that were very telling were that, just because we had the slow start doesn't mean that the season's not going to be busy. And I think that's one of the things we all saw kind of bubbling out there in social media and other places that, well, where are the hurricanes? Like, well, guess what? Here they are.
Yeah. It was, I think in the weather world, it was bold to have a lot of the hurricane forecasts like NOAA and Colorado State to continue with an above average forecast, especially when you're thinking of how quiet it's been. But there are reasons behind the forecast, and sometimes what doesn't seem natural, just given the circumstances we're in, turns into reality. And we have certainly over the past, since mid-September, has heated up with the tropics, and it doesn't look like it's going away anytime soon here. And it looks like we will meet a lot of these forecasts that did come out, maybe on the lower side or slightly below, but generally within the range there. So, it's always good to have Jhordanne on. Like we were saying, I've had her on a different show 2 years ago. Really nice and, wealth of information, like you said, Sean.
Yeah, she's great. Matt, what do you think? What are your closing thoughts, man?
Well, yeah, there's a reason why hurricane season lasts until November 30th. You can't let your guard down, even though we went the whole month of August without anything happening, which was, I think, a big surprise for many. We figured something would have to pop in August, and it didn't. But then early September, going through Labor Day, where are they? Well, now they are really popping up. Looking at all the areas watching. Again, to stress, we were recording this on September 22nd. And there have been 7 named storms, but that is probably going to be changing. I have a feeling like the next few weeks are going to be the key time frame here, because you can't let your guard down, especially in October. There have been some big ones in October, some very notable storms. How about Superstorm Sandy, Joe? You're familiar with that. Hurricane Michael was in October. So we have had some big ones in the month of October, and that could certainly happen again. And not to forget about November, the forgotten month, I feel like, of hurricane season, because usually that is when things are winding down, but especially when you have really warm sea surface temperatures like we're seeing this year. If we can get rid of the dry air and the shear like we were dealing with in the first part of the season, got to keep an eye on November as well, because those waters are still going to be pretty warm, it looks like.
Yeah, I mean, even right now, again, we're recording this on the afternoon of the 22nd of September. You know, we've got Fiona that's on the way to the Canadian Maritimes. Gaston is out in the Northern Atlantic. We've got probably what's going to be Hermine coming in the Southern Caribbean. And there's two other waves that the Hurricane Center is monitoring in the Eastern Atlantic. So we are in the thick of it, and it is not going to back off anytime soon. As we always are fond of saying, it only takes one for you to make it a busy year. So with that, we're probably going to go ahead and close up the shop for the week. Kirsten had to run, take care of some family stuff. But for Kirsten Lang in Tulsa, Joe Martucci in Atlantic City, Matt Holliner in Chicago, meteorologist Sean Sublett in Richmond, Virginia at the Richmond Times-Dispatch. Thanks for joining us on the Across the Sky podcast, and we'll talk to you next week.
All right.
An important message from Blue Ridge Hospice. There may be several hospices now claiming to serve the area, but Blue Ridge Hospice is the only local hospice that has been serving here for 40 plus years, operates the only hospice inpatient care center, conducts the only community-wide grief and bereavement programs, offers a nationally recognized music therapy program in conjunction with Shenandoah University, outscores every other Virginia hospice in Medicare's quality scores, and so much more. Blue Ridge Hospice, the first, the best. Find out more at blueridgehospice.org.